All right, this is section 2.2, adding rational numbers. And we talked about how rational numbers are basically fractions and decimals, are what they're most commonly referred to as, but they're also integers, whole numbers. So we're going to specifically talk about fractions and decimals today. We'll start with decimals. So if I'm adding decimals and I've got negatives, and that's kind of what we've been talking about so far this year, I need to first check if I've got same signs or different signs. Because if I have same signs, I'll end up adding, but if I have different signs, I'll end up subtracting. So we want to check the signs. We also want to make sure we line up the decimal points. That's really important. Something you have to do if you're adding or subtracting is line up the decimal points. And then we're going to write the larger number on top. The larger number. Now, it doesn't really matter if you're adding, but if you're subtracting, the larger number has to be on top. So if you just get in the habit of always putting the larger number on top, you'll be fine no matter what. And then the final step will be to add or subtract, regardless or depending on what you've got for your signs, same signs or different signs. So let's look at some examples. All right, so for the first example, negative 4.05 plus 7.62. The first thing you want to check are the signs, and we have different signs, which means we're going to subtract. So we're going to write the larger number on top, 7.62 minus 4.05, also making sure we line up the decimal points. And then we have to borrow from the 6, make it a 5, make this a 12. 12 minus 5 is 7, 5 minus 0 is 5, drop down the decimal point, and 7 minus 4 is 3. And then don't forget, if we have different signs, we subtract and we keep the sign of the larger number. And because my larger number is positive, then my answer is going to remain positive 3.57. For example B here, we've got same signs. So we're going to keep the sign and we're going to add. So it's going to be negative, and then we're going to add. Again, I'm going to put the larger number on top, 8.15, plus 4.3, and I'm going to put a 0 there. So I have my decimal places and my columns lined up. And remember, we said our answer was going to be negative. So 5 plus 0 is 5. 1 plus 3 is 4. Drop down the decimal point. 8 plus 4 is 12. Same signs, keep the sign, and add makes it negative 12.45. Here in example C, we have different signs again, so we're going to subtract, putting the larger number on top. That's the 2.7. So 2.7, we have different signs, so we're subtracting. Again, making sure I line up the decimal points, which means I have to add another 0. And you can't subtract 0 minus 5, so we borrow, and that gives us 10 minus 5, which is 5. 6 minus 6, which is 0, drop down the decimal point, and 2 minus nothing, which is 2. Keep the sign of the larger number, and the larger number is negative this time. So keep the sign of the larger number, then you'll be exact. So we've got negative 2.05 for our answer. And then example D, again, we have different signs. So we're going to subtract, and we're going to write 12.235 minus 10.2, and we're going to add some extra zeros there. Different signs, subtract. Keep the sign of the larger number. You can already tell that the larger number here is negative, so we will get a negative answer. You can actually do that before you even subtract. 5 minus 0 is 5, 3 minus 0 is 3, 2 minus 2 is 0, drop down the decimal point, 2 minus 0 is 2, and 1 minus 1 is nothing. So our answer is negative 2.035. And you can see we're really not doing anything new. We're just combining what we already know about decimals with our integer rules, which says when we're adding, we have to check whether we have same signs or different signs. All right, so fractions. Fractions obviously take a little bit more work than what decimals do. So one thing we're going to want is to find a common denominator. And you want to find a common denominator anytime you're adding or subtracting fractions. Specifically, in this case, we want to find the least common denominator. That's going to save us from having to reduce a whole lot. Maybe we won't even have to reduce at all if you find the least common denominator. The second thing is if you change the denominator, and this is a commonly forgotten thing, but you have to change the numerator of that fraction too. Otherwise, you completely have changed the fraction. You want to make it have the same value. So if you times the denominator by 5, you're going to want to times the numerator by 5 as well. And then check whether we've got same signs or different signs, because if we have same signs, we'll add. And again, if we have different signs, we'll subtract. And then one thing you have to do with fractions that you don't have to worry about with decimals is that your answer must be reduced. So let's look at a few examples. In example A here, we have -7/8 plus 1/4, and we need to find a common denominator, and our common denominator is going to be 8 because we can just take 4 times 2, and that means 1 times 2 as well. And since we're not changing the first fraction, the first denominator, we can just rewrite the whole fraction as -7/8 plus 2/8. Now what I would do is I would write this negative sign up with the 7. That way you can actually look at it when you're adding or subtracting the numerators. Now that we've got a common denominator, we want to check the signs. We want to subtract here because we have different signs. So because we have different signs, 7 minus 2 is 5. Remember, different signs subtract, keep the sign of the larger number, so it's going to be -5, and then we just keep that denominator as it is. So -5/8 is our answer for example A. For example B, our common denominator is going to be 6, because if we just do 3 times 2, we'll get that same denominator as the other fraction, so it's going to give us 16/6 plus -5/6. We don't need to change that fraction, so really what we're doing is timesing it by 1, which doesn't do anything. So we're going to leave it alone. And again, we have different signs, so we're going to subtract. 16 minus 5 is 11. And then we have 6, and we want to keep the sign of the larger number, so that's a positive 11/6, and that does not reduce. You could write that as a mixed number if you wanted to. 6 goes in 11 one time with 5 remaining, but I'm okay if you just write it as an improper fraction, as long as it's reduced, and this one is. In example C, we have 2 plus -7/2. 2 can be written as 2/1. Whoops. Can be written as 2/1, which is a fraction now. So you can turn any integer into a fraction by putting it over 1. And then I need a common denominator. Well, if I just multiply that by 2, I will get 2 as my common denominator. So 2 times 2 is 4. And 1 times 2 is 2. Plus -7/2. So we've got different signs. So again, just looking at the top numbers here, we have different signs. So we're going to subtract, keep the sign of the larger number, makes it -3/2. And again, you can just leave that as a reduced improper fraction. And then example D, we've got mixed numbers. Well, there's actually 2 different ways you could do this. You could leave them as mixed numbers, or you could write them as improper fractions. So let's start by writing them as improper fractions. 3 times 5 is 15, plus 2 is 17, so -17/3, plus 4 times 1 is 4, plus 1 is 5. So we've got -5/4. We still need a common denominator, and that common denominator is going to be 12. That's the first multiple of 3. That's also a multiple of 4. So 17 times 4, go off to the side there, is going to give us 68, or -68 here, plus 5 times, whoops, I wrote that down wrong. That's supposed to be 4 times 3. So 5 times 3 is 15, or -15, and we have same signs, so we're going to keep the sign and add. So keeping the sign, it's going to be negative, and 68 plus 15 is going to make, let's see, 13, carry the 1, it's going to make 83. So -83/12, and that does not reduce. You can check, 2 doesn't go in. 3 doesn't go into 83. It does go into 12, but it doesn't go into 83 because 8 plus 3 is 11. Remember, you can just add the digits up to see if 3 goes in. So since 3 does not go in, then we just leave it as -83/12. So another way you can do this problem is you can keep them as mixed numbers. If you choose, this is optional, but some people find this easier. If you keep it as mixed numbers, you don't have to change them into improper fractions, which again, if you change them into proper fractions, sometimes you get big numbers like -68. So in that case, if you want to leave them as mixed numbers, you still need a common denominator. So times by 4 and times by 4 gives you 8/12. And times by 3 and times by 3 gives you 3/12. So -5 and 8/12 plus -1 and 3/12. So in order to do this, I have to do the fraction part first, then the whole number part. So I'm adding still because they have different signs, or sorry, same signs. So we're adding. So we're doing the fraction part plus the fraction part. 8 plus 3 is 11. So 11/12. And then now you add the whole number parts, which remember there was a 1 right there before I covered it up. So 5 plus 1 is 6. So -6 and 11/12. And actually, if you were to write this number as a mixed number, this improper fraction as a mixed number, 12 goes into 83 6 times, and 12 times 6 is 72. And 83 minus 72 is 11, so there's 11 little guys left over. So you actually get the same answer as we did over here, but with a little bit of less work. So if you know how to do it, writing them as mixed numbers and leaving them as mixed numbers could actually be a little easier than the improper fractions. So this next example, I'll do both ways so you can see. First, I'll start by finding the answer using improper fractions. So 8 times 2 is 16, plus 1 is 17, so 17/8, plus 5 times 1 is 5, plus 2 is 7, so -7/5. Need a common denominator. The first multiple of 8, that also is a multiple of 5, so I know multiples of 5 end in a 5 or a 0, is actually 40. So that's going to be my common denominator is 40. Which means I times by 5, and 17 times 5, again, going off to the side to do extra work here. That is the issue with improper fractions, is that sometimes they can get big numerators like this. And 5 times 7 is 35, here are the 3, so 85/40, plus times by 8, that's a -56/40. We've got different signs, and we could actually tell that even up here in the original problem, we could have seen that. So we're going to subtract. So 85 minus 56. Got to borrow from the 8 to make it a 7. And 15 minus 6 is 9. And 7 minus 5 is 2. Keep the sign of the larger number. Then you'll be exact. So 29, that's a lot of work, but 29/40 is our answer. Now, if we were going to keep them as mixed numbers, then I still would need a common denominator, and it would still be 40. So I would times by 5 and times by 5 to get 2 and 5/40, plus -1 and times by 8 and times by 8, 16/40. So a little less work of converting those to common denominators because I didn't have the big improper fraction. My numerator wasn't as big. And then I've got different signs, so I'm going to subtract. And this is where this can get confusing. If I've got different signs, I have to make sure I have the larger number written first, which I do in this case. And then I'm subtracting 5/40 minus 16/40. And you know what? You can't do that because you can't take 16 away from 5. So you got to borrow from the 2 and make it a 1. And then you're borrowing, not 10 like we normally do, like I just did over here. You're borrowing 40 because that's what the denominator is. So 40/40 is 1. You're borrowing 40/40 and you're adding them to the 5 you already had, giving you 45/40. So now I do 45 minus 16. I know 45 minus 15 is 30. Take one more away and you'll get 29/40. So once you subtract the fraction parts, now you have to subtract the whole number parts. Now remember, this was a 1. I just wrote over it. And now since I had to borrow from the 2, this makes this a 1, and 1 minus 1 is 0. So there is no whole number. So you get 29/40, which is exactly what we got when we did it the other way as well. A little less work, a little bit more complicated perhaps. So I understand if you just want to stick to what method you like the best there. So in this final example, it says the table shows the annual profits in billions of dollars by financial company from 2008 to 2012. Positive numbers represent gains, negative numbers represent losses. Which statement describes the profit over the 5-year period? So I've got 2 years that they actually lost money here in 2008 and 2009. And then the rest of the years they gained money. So since these have the same signs, I'm going to start with them. I'm just going to add all these numbers together, and you can add in whatever order you want to. So I'm going to stick with the 2 negatives. Same signs, keep the sign, and add. 4.75 plus 1.70. 5 plus 0, 7 plus 7 is 14, carry the 1. And 1 plus 4 plus 1 is 6. And remember, it was same signs, keep the signs. So altogether in the first 2 years, they lost $6.45 billion. And I guess that makes sense, since to start a company, usually you end up losing money first couple of years. It takes a while to gain money when you start your own business. And then these last 3 numbers are positives. So I'm going to go ahead and add them together, 1.7, 0.85, and 3.6. Make sure I line up my decimal places. Put some extra zeros if I need them. And 5 is the first number. 7 and 8 make 15. 15 and 6 make 21. Carry the 2. And 2 and 1 make 3. 3 plus 3 is 6. So then I gained $6.15 billion. So then if I add these 2 numbers, you'll notice I have different signs. So I'm actually going to subtract. Write the larger number on top when you subtract. You can already tell, since the larger number is negative, our answer is going to be negative here, so we still have lost money. 0, 3 point. Okay, so altogether, over the course of these 5 years, this is negative, we have lost 0.3, or how about negative 0.3 billion dollars. That is a lot of money to lose. Actually, $300 million, but still a lot of money to lose. So negative $0.3 billion.